Hello, Algebra 2 students. This is a Regent review for Unit 6, Square Root Functions. Each section that I go over is a different standard that the Regent could test you on. So the first was operation with radicals, and it's important to understand rational exponents. X to the m over n, the denominator of your exponent, is the degree or the index of your root. So you could just think root for denominator, power shown for your numerator. So essentially that's saying x to the m over n is the nth root of x to the m. So let's start doing this specific problem. We have a square root, right? And think about it, how many even multipliers do you split a square root into? 2. So essentially there's a 2 there, right? It's the most basic root, so they don't write the index. So that is 16x squared to the 1/2 times x to the 2 over 3 plus 8x to the 5 to the third root would be the 1/3 power. Now you have exponents within exponents, so you could multiply your exponents. That's your power law. Very common mistake. Students will make that multiplication that I just showed with that arrow, but they'll forget to distribute the exponent to the exponent on the 16, that invisible one. So we have 16 to the 1/2 times x to the 2 over 2 times x to the 2 over 3 plus, we're going to do the same thing here. Make sure you distribute to the invisible 1 exponent on the 8. So 1/2 power on the 16 is essentially just saying the square root. So square root of 16 is 4. You could also put it in your calculator if you feel like you can't do that math. X to the 2 over 2 is just x to the 1, first power, times x to the 2 over 3, plus 8 to the 1/3 is the third root of 8. 2 times 2 is 4, times 2 is 8. So it's going to be 2. So x to the 5 over 3. Let's simplify. You have a common base, so you could add your exponents as your product law. So 1 plus 2/3, 2x to the 5 over 3. So 1 is essentially saying 3 over 3. 3 plus 2 is 5, so 5 over 3. Now you have a common term, alright? You have like terms, so you could combine those. That's just 6x to the 5 over 3, which 3 would be the degree of your root, so 6, the third root of x to the 5th power. And that's your answer. Something else that you could have done, rather than doing all this work, you could have just said x equals something. Say x equals 7. You'd plug in 7 for where you see x in your calculator, and then you plug it into your options and see which one you get the same number for. Another thing you could have done, you could have put this in your y equals, put this in y equals, this in y equals, this y equals, and this in y equals, and see which one is on top of that function. Right? Or go to second graph and see which table is the same. So you have some options. Remember, radical and rational solutions, you must solve for extraneous solutions. So, first step, since the radicals are already isolated, you could square both sides. 56 minus x equals x squared. We want this to equal, it would be a quadratic that equals 0. So you could add x, subtract 56. So we have x squared plus x minus 56 equals 0. We could factor this. If you couldn't factor it, what you would have to do is use quadratic formula. But there's a negative sign, so it's going to be different signs. What factors of 56 subtract to positive 1? 7 and 8. So you're going to have negative 7, positive 8, because 8 minus 7 would be positive 1. And then your two zeros would be negative 8, positive 7. We are not done. So if students could get to this point, right? A lot of times they're so confident in their answer that they just stop right there. Remember, you must check for extraneous solutions. This probably isn't your answer. So, with radical functions, the way you would check that, you just plug in. So first let's check negative 8. And then we're going to check 7. Square root of 56 minus negative 8 equals positive 8. Does positive 8 equal negative 8? No. So what I do, I'm going to cross out, I'm going to say extraneous. Let's check this one. 56 minus 7 is 49. Square root of 49 is 7. 7 equals 7. Is that true? Yes. So your only real solution would be 7. Again, just imagine you were taking the region on your own right now. And you did all this work, and you got to a solution. Are you going to remember that you have to check for extraneous solutions? If not, really take a mental note. Say, I have to check for extraneous solutions when I am solving radical and rational functions. The two R's. If it's a fraction or if it has a square root. Okay, let's do the same thing. Square both sides. Subtract b squared. Factor this, it's a difference of perfect squares. So different signs. Square root of b squared is b. Square root of 64 is 8. If you didn't want to factor it, you could have, it's not a trinomial, so actually you could have just solved. You could have added 64 and then taken the square root. And when you take the square root of an unknown, you have to remember plus or minus, right? Or you could factor, or you could use quadratic formula. If you use quadratic formula, you know your a is 1, your b is 0, and your c would be negative 64, right? So just keep in mind you have different options, and your b will be plus or minus 8. So now you did this. What do we have to do? We have to check for extraneous solutions. So 8 or negative 8 equals square root of 2 times negative 8 squared minus 64 positive 8 equals square root of 2 times 8 squared minus 64. So, alright, we plugged into our original. So negative 8 squared is negative 8 squared is 64. 64 times 2 is, it doesn't matter because you're subtracting 64. So that's just going to give you 64 again. Square root of 64 is 8. Does negative 8 equal 8? No. So that is extraneous. Now for this one, 8 squared, 64. 64 times 2 minus 64 is going to be 64. Square root of 64 is 8. 8 equals 8. So your only actual solution would be 8. Doesn't necessarily mean that you're always going to have an extraneous solution. You could have two real solutions. You could have 0 solutions, right? Could have even more than 2 if it was more than a quadratic. Okay, square both sides. X squared minus 4x minus 5 equals 2x minus 10 squared. So I'm just going to expand that out. Multiply out, so you're going to just distribute. 2x times 2x is 4x squared. 2x times negative 10 is negative 20x. Negative 10 times 2x, negative 20x. So you add those, negative 40x. Negative 10 times negative 10 would be positive 100. We could subtract x squared, add 4x, add 5. 4x squared minus x squared, 3x squared. Negative 40x plus 4x is going to be negative 36x. 100 plus 5 is 105. You could try to do AC method and see if that would work. Or you could also do factor and big grouping possibly. But the possibility that it is not factorable could, really weigh on you because it's just going to waste your time. So I recommend just doing quadratic formula. So, and by the way, this is also on your read and reference sheet, so you don't have to have it memorized. I always recommend listing out your A, your B, and your C. Your A is just 3. Your B is negative 36. Your C is 105. So we have negative 36 plus or minus negative 36 squared minus 4 times 3 times 105 over 2 times 3. Negative 36, positive 36. 2 times 3 is 6. Plus or minus square root. Let me put that in my calculator. 36 squared minus 4 times 3 times 105. Get 36. Square root of 36 is 6. Excellent. So plus or minus 6, because the square root of 36 is 6. So put that in your calculator. 36 minus 6 divided by 6 is going to be 5. And then do the same thing, but 36 plus 6 divided by 6. And you get 7. So, again, don't fall for that trap of it being 5, 7, because remember what we have to do. Check for extraneous solutions. I know it's a lot of work. By the way, another option you have, besides just plugging in, because it's multiple choice, option that you have, you could put this in your calculator for y equals, this in your calculator for y equals, and then finding the point of intersection by doing second trace, intersect, enter, enter, enter. So you have a lot of options, especially with multiple choice. Just plug in, and you can check your answers. So, we have to check x equals 5, x equals 7. And just to get in the good habit, even though it's not really necessary in this case because they're not negative, you should be doing that. So I get 0. 2 times 5 is 10. Minus 10 would be 0. So that checks. 7 squared minus 4 times 7 minus 5 is 4. 2 times 7 is 14. 14 minus 10 is 4. That worked out. Your answer is 5, 7. So in that case, you had no extraneous solutions. Okay. In this case, I mean, distribute out. There's no point in not doing it first. So distribute out. We have 2x plus 30 minus 9. 30 minus 9, 21. We want to get rid of that radical, but in order to do so, we have to isolate the radical, get it by itself. That x was not in the radical, right? So 2x minus x is just x. So now you could square both sides. Distribute. X times x is x squared. X times 21, 21x. 21x plus 21x would be 42x. 21 times 21 is what? 441? Let's check. 441. Okay. Subtract 6. Add 2x. And now we have a quadratic that equals 0. So 41 minus 6. You could check if it's factorable, but just use your quadratic formula. List out A, B, and C. 1, 44, 435. X equals negative 44 plus or minus radical 44 squared minus 4 times 1 times 435 over 2 times 1. Negative 44 over 2, plus or minus, radical. Putting this in my calculator, just the radicand, what's in the radical. You get 196. Believe that's a perfect square. It's 14. So, x equals negative 44 plus or minus 14 over 2. Let's put that in our calculator and find our two possible solutions. Negative 44 minus 14 divided by 2 is negative 29. We're going to do the same thing, but add the 14. You get negative 15. Are we done? No. You must check for extraneous solutions. I'm hoping at this point it's getting repetitive. Don't forget to check radical and rational functions. So, plug that into the original. Square root of 6 minus 2 times negative 29 plus negative 29. You get negative 21 on the left side. Let's see if it's the same on the right side. You get negative 37. Not the same. Extraneous. Okay, let's do the same thing for 15. And for the sake of time, I'm just not going to write that, but doing the same thing for 15. I get negative 9 equals -9. That worked. So your answer is x equals -15. Okay. A lot of the same question. So, subtract x. You want to isolate the square root. Square both sides. Expand the square. Distribute. Get this to equal 0. (25 plus 7 is 32. -12x plus x squared. Probably. If you want to rewrite this in standard form, if that's easier for you, do it. This is a plus sign, so same signs. Both signs are going to be negative. Are there factors of 32 that equal 12? 8 and 4. So you're going to get x equals +4, +8. If you don't just immediately see it, set those factors equal to 0 and solve, right? X minus 8 equals 0. You add 8 on both sides, you get +8. It's always going to be the opposite sign. So are we done? At this point, you should not be answering that wrong. We have to check for extraneous solutions. Plug into the original. There's no way that both of these could be right because we know definition of a function. Can't have the same input, give different outputs. You get 5. 5 equals 5. So your answer is going to be x equals 4. But just to make sure we did everything right, let's plug in 8. You get 11. 11 does not equal 5. So 8 is extraneous. That's, by the way, that's a +4. It's just an equal sign. Okay. There's some easier questions. Oh my goodness. The speed of a tidal wave in hundreds of miles per hour can be modeled by this equation. Algebraically determine when s equals 0. So plug in 0 for s. Isolate the square root. Square both sides. Expand. Distribute. This is actually the biggest mistake with this question that students make. We know it has to equal 0. You can't just say that this equals 0. You have to subtract t on both sides. It seems obvious, just make sure, you know that you're comfortable with doing everything correctly. And then you shouldn't make mistakes like that. You probably could factor this, but rather than taking the risk of, wasting time, use quadratic formula. This one you really have to use parentheses because it would be wrong because it's negative to b. That's why I always recommend using parentheses. Okay. 25 squared minus 4 times 36 is 49. Square root of 49 is 7. Now we could find the two possible solutions. $2.25. Do that with plus now. 4. You have two possible solutions. Plug that into the original equation. Square root of 2.25 minus 2 times 2.25 plus 6 is 3. 3 does not equal 0. That's extraneous. Now we're going to do the same thing for 4. You get 0. 0 does equal 0. So t would equal 4. So the time is 4 when s equals 0, when the speed is 0 of your tidal wave. There is a second part to this question. How much faster was the tidal wave at 1 hour than 3 hours? T is time in hours, so you just have to plug in. So at 1 hour, it'll be radical 1 plus, minus 2 times 1 plus 6. At 3 hours, it'd be radical 3 minus 2 times 3 plus 6. Square root of 1 minus 2 times 1 plus 6 is 5. So the speed was 5. Now we're going to do the same thing with 3. So square root of 3. And that's going to be irrational because square root of 3 is not a perfect square. You get 1.7320500808. To find how much faster it was at hour 1, you're going to have to subtract. So 5 minus 1.7320500808 equals 3.2679491. It says to justify your answer, and it also says to the nearest mile per hour. So, say the tidal wave was about approximately 3 miles per hour faster at hour 1 than hour 3. Okay. A Foucault pendulum can be used to demonstrate that the Earth rotates. Time t in seconds it takes for one swing or period of the pendulum can be modeled by this equation, where L is the length of the pendulum in meters, and g is a constant of 9.81 meters per second squared. The first Foucault pendulum was constructed in 1851 and has a pendulum length of 67 meters. Determine to the nearest tenth of a second the time it takes this pendulum to complete one swing. So that's the first question. So we're looking for the time it takes. So t equals 2 pi. The length of that pendulum was 67 meters. L is in meters, so we're good. We could just put 67. The g is a constant. It's 9.81. All you have to do is put that in your calculator. 2 pi square root 67 divided by 9.81. So t is approximately 16.42036347, nearest tenth of a second. So, whoops, didn't mean to move the decimal. 16.4 seconds. Let's do question 2 now. Another Foucault pendulum takes 9.6 seconds. So now we have the time. We want to determine the length to the nearest meter. Length is L. The constant is going to stay constant. So you divide by 2 pi. You want to isolate the square root. Right now, let's leave it as 2 pi because it's not going to be a pretty number. So 9.6 over 2 pi equals the square root of L over 9.81. Square both sides. So now we have 9.6. Gotta write this neater. 9.6 over 2 pi squared equals L over 9.81. Just multiply by 9.81 on both sides. And you have what your L is. L equals 9.81 times 9.6 divided by 2 pi. Make sure you put parentheses around your whole denominator. Squared. You end up getting 22.9008571, nearest tenth of a meter, so L is approximately 22.9 meters. Okay. Radical and rational exponents. This is an easy one. Explain why 81 to the 3 over 4 equals 27. So, remember, x to the m over n equals the nth root of x to the m, or vice versa. It could equal the nth root of x to the m, right? Because you have that commutative property of multiplication, even with exponents. So, 81 to the 3 over 4 equals the fourth root of 81 to the third power. The reason I did it like this rather than like this is because if I did it like this, I'd have to do 81 to the third, and that would give me a huge number. I want to do this in my head. So, the fourth root of 81. Fourth roots are easy. All you have to do, take the square root and then the square root again. So, square root of 81, 9. Square root of 9, 3. So now we have 3 to the third power. 3 to the third power. 3 times 3, 9. 9 times 3, 27. We just proved it. Okay. Excellent. And now we have this question here. Okay, I like that we have some rational exponent questions. Justify why this is equivalent to this using properties of rational exponents. So the third root is just the 1/3 power. The fourth root is the 1/4 power. Remember, let's pretend there was like a 7 in front of there. Like, let's say there was a 7 here. Remember, you have to distribute the exponent even to the coefficient. But there wasn't. So we have exponent with an exponent, power law. So you can multiply x to the 2/3, y to the 5/3. Same thing goes for this. X to the 3/4, y to the 4/4. If you want to simplify, you could simplify. It looks like most of them are simplified except for that one. 4/4 is just 1. Now, you have common bases, right? And you're dividing, so you could use your quotient law. So, with the common bases, you just subtract exponents. X to the 2/3 minus 3/4, y to the 5/3 minus 1. I'm going to put that in my calculator. So 2/3 minus 3/4 is negative 112. 5/3 minus 1 is 2/3. And we just showed the math. We justified it using math. If you wanted to go further with the explanation, you could have stated power law. If you go, vertically, that would be better because then you could write power law next to it. And then you could say quotient law. Right? And that's all we had to do. What if I wanted to re-express this in simplest root form, right? And I wanted to get rid of negative exponents. Well, a negative pushes it to the denominator. So this is and by the way, I'm going further. The question ended here. But a negative pushes the x to the exponent. So this would be the same as saying y to the 2/3. Did I say exponent? To the denominator. So y to the 2/3 over x to the 1/12. And now we know this is the third root of y to the second, and this is the 12th root of x. That would be simplest root form. They're not common radicands or common like terms or common bases, so you can't combine those at all. Okay, hopefully this helped. Thank you.